Hello everyone and welcome back to the workshop. I hope that you're all well. If you can hear a bit of noise in the background, that's my heater running. Winter is definitely making herself felt now here in the south of England, especially in the evenings. The temperature's dropping quite a bit. So I hope that you're keeping toasty warm wherever you are. This video we are back on with the D7 Bantam. We're going to have a look at the exhaust system. If you watched my previous videos, you'll know that I have the later large bore silencer and the earlier small bore downpipe. Couldn't get my words out. So we're going to make a part to fix that problem and make the two parts play together nicely. It is largely a machining video, most of it done on the lathe. The milling machine does make its debut in a video, not being worked on but actually doing some work, so that's good. And we do a bit of a trial fit at the end as well, so I hope you enjoy the video and that you get something out of it. I always say this, but I'm going to say it again. Thanks very much indeed to everyone that has subscribed. We've got quite a number of new subscribers, so welcome aboard. I hope that you enjoy the videos going forward, and indeed catch up on the back catalogue and see all the things that we've been up to. Those of you that have been with me for a while, thank you very much indeed for sticking with me and for choosing to spend some time with me. It's very much appreciated. And if you're watching and you're not subscribed, don't forget to hit the button. It won't cost you a shilling. Hit the subscribe button, and don't forget to hit the like at the end if indeed you did like the video. So right, let's get on and see if we can fix this BSA exhaust system. So here we are back working on the D7, and we're working at the exhaust system this time around. You may recall we have the later silencer with the larger bore and the early downpipe, which is a narrower bore, and to make the two play well together we need to make a reducing sleeve, and we also need to incorporate some length into it so that we take up the gap between where the downpipe ends and the silencer begins, and that's what we're doing here. One of my viewers, I think it was Kev, said it'd be nice to make it out of stainless steel, and it certainly would, but the price of it at the moment is quite heady. So this piece of 6061 came my way, and that's what we're going to use. Plenty of trials bikes use aluminium exhaust components, so yeah, it would have been nice to use stainless, but for the time being, at least, we're going to use this. We've got a diameter turned here, which will fit inside the silencer. You may recall that sleeve that I made to get the engine running, and basically we're making an extended version of this, but with obviously not with the big slot in it, because the whole thing doesn't have to clamp around the downpipe. So this diameter here will fit inside the silencer. We'll have the flange like this here, which will be the same diameter as what we've turned here, and then we'll turn another diameter to extend forward and capture the downpipe, and then the whole thing will be bored to the diameter of the downpipe. We'll have a slot here, just a thin one, probably a saw cut with a hole at the end to stop it from spreading, and a clamp around the outside of here to clamp the downpipe, and then a clamp around the silencer here to clamp this piece inside, and that should do the trick, I think. So hopefully I've explained that reasonably well, and it didn't all sound like waffle. And so with this diameter done, we'll turn it around and we'll allow for the flange, and then we'll reduce the diameter. Okay, so you're perched up on the tailstock there. Hopefully you'll get a good view of what's going on, and I've just measured the diameter that we need and zeroed the caliper, so we're using it as a comparator, and we'll just see how much we need to take off. I'm just using the caliper because it's as accurate as we need to be. So about almost 6.6, 6.55. What we got there? 6.53. Yeah, so if we take 6.5, and we should be good. So I've already dialed in the amount that we need for the flange, so the lathe carriage will stop and give us a nice 6mm flange, which should look quite nice. I've set the stop and we're ready to do some turning, so let's take a cut. What speed are we at? Yeah, that should be okay. Just going to give that insert a bit of a clean. Bit of squirty magic, which works really well on this this grade of aluminium. It really improves the finish. It's just your sort of standard maintenance fluid, whatever it is you prefer to use. Okay, and we'll take a mill. I think we can afford to go a bit more aggressive than that, can't we? There we go, that's more like it. Well, we're making Christmas decorations again. We've just got my pliers. Turn the feed down a little bit. Just experiment with it. That's better. Let's put another cut on, see what we're like. Right, I'm going to mess around with the speeds and feeds. I shall bring you back when we're getting something like, you know, what we want to see. Okay, running a bit slower, a bit more depth of cut. same feed rate. It seems to be a lot happier, so we'll live with that. Incidentally, if anybody is a little bit short of Christmas tree tinsel this year, do let me know, because I've got quite a lot. Lots of stringy aluminium snow if you need it. Right, so after this cut we've got about another 2 mil to come off. Camera battery's getting a little bit low, so I'm going to pause you there, and I'll bring you back when we've got the diameter and we're ready to put a hole through the thing. Right, so we are ready to put a hole through it now. We're down to diameter, and that'll be our next job. Now, remember I mentioned those Christmas decorations? Well, I wasn't kidding, you know. Look at that. Genuine Retromeccanica Christmas icicles. I think it could be a good line. So don't go complaining when you miss out and you don't get any. Aid from AG Engineering said that I should knit them all together and make aluminium welding rods. And I've got to be honest with you, I never know if he's pulling my leg or not. Anyway, I think it's time to drill a hole. So we'll do that. So this is my set of blacksmith drills, reduced shank drills. I believe they're called different things around the world, but here they generally tend to be called blacksmith drills. And I think they're all a 1/2 inch or 30mm shank. Fits easily into a Jacob's chuck, and they go from 14mm all the way up to 25. I've had this set for quite a few years now, and they've been really useful. I haven't used the super large sizes very often, but as I say, yeah, very, very useful. I can't remember where I got them from. It may have been RDG Tools here in the UK, I'm not sure, but they're an imported set. I didn't pay an awful lot for them, but I'm sure many of you will have them. If not, it's well worth picking a set up. I've got a few loose ones as well that I've bought that, you know, weren't included in the set. I think that's an 18.5. I bought that for I think it was drilling up to a reamer. You know, I was about to ream a hole. I didn't have a drill bit close enough. I think that's what that was for. The only thing I'll say really is there's quite a lot of surface area. The flutes are nice and wide, so they do clear the chips very well. But if your lathe isn't particularly powerful, mine's not bad, but it's, you know, it's not a monster. On the larger drill bits, you've just got to be careful that you don't stall the machine, because all that surface area can be a problem. So keep them well lubricated, clear the chips quite often, and you shouldn't have an issue really. I'm going to use these to start opening up the hole in the exhaust adapter, and I'll show you one of them going through, and then I'll just carry on until we get to a size that I can get the boring bar in quite comfortably. And yeah, I just thought I'd show you that kit. So let's get on and make a hole. So I've got you in your favourite position up on the tailstock, so you get a really good view of everything that's going on. I've already put the 14mm blacksmith's drill through, and we're going to move on and put an 18 through. I'm using fairly viscous cutting oil. I'd normally use sort of a maintenance spray type of thing for aluminium, but because there's quite a lot of surface area and quite a lot of friction with these drill bits, I'm using Super Cut, which is quite a thick, clingy cutting oil. So we'll start off with a little bit of that, and move into position, and we'll put the drill through. See how we get on. Keep the pressure on so it doesn't start to chatter. We are getting some serious Terry Castles coming out of there. You'll have to go back in my videos if you want to know what a Terry Castle is. Just give that a bit of a clear out the way. Go back at it. Take the lid off, Dean, it makes all the difference. Excuse my intrusion. Let's get these bits out of the way. You can hear the lathe working for its living. We are at 240 RPM. We got all the way through with the 14mm, so I'm hoping that turn the pressure off, look. Hopefully we can just go straight through with this one. The problem is, obviously, the flutes get right inside the bore, and the chips have nowhere to go, and you can end up with a situation where you get a jammer. So we should take our time. Once it's big enough for the boring bar to go in, we'll probably just finish off with a boring bar. And that's the thing. Yeah, I actually think this is probably going to be the last drill bit we use. We had a bit of a grab there, didn't we? We're really we're sort of beyond the capability of the drill, really, because it can't clear the flutes. I'm sure we'll get there. Hope I don't make you seasick with all this backwards and forwards. There we go. Okay, so we've got our 18mm all the way through, and I think we'll probably switch to the boring bar at this point. So I shall get set up for that, give the lathe a little bit of a clean, because we are literally turning into a festive wonderland, and it's just getting a little bit too messy, really. So get the boring bar set up and I will bring you back. Right, well, I've moved you. You're now magnetically attached to the milling head column. So that's a different place. You've not been there before, but it was the best place really to get you a view of what the boring tool is going to do. Now, we've talked about this boring tool before, and I have to tell you, he's raised his game quite a bit. He's got some hobbies. I think he's taken up painting. So yeah, he's definitely becoming more interesting. So hopefully he'll do a good job for us, and we'll get this hole out to size. So I'll just probably do one pass on the camera, and then I'll bring you back when we're getting somewhere near, because I realised that drilling operation took quite a long time, and I don't want to bore you. So I don't want to bore you. See what I did? Anyway, we will take a pass with this cutting tool and see what kind of results we get, and then, as I say, I'll bring you back. So without further ado, let's get to it. I can't bore all the way through with this tool, but it doesn't really matter. It's not as though we're doing a precision piece of equipment, so we'll just have to flip the piece around, the workpiece around, just to get the last little bit. But as I say, it's an exhaust, not a not a bearing, so we'll be all right. So I've zeroed off. I've taken the backlash out and put some cut on, and give it a go. That's a 1mm cut, and I'd say it was coping admirably, but it is only aluminium after all. RPM is 315, and I think we're doing all right with that. Perfect. Right, I'm going to switch you off, and you will come back when we are getting something like to size. Well, things have moved on a little bit, and we're over at the milling machine. And I think this might be the first time I've used the milling machine in a video, but I'm not entirely sure. I can't remember. It may well be. As you can see, the part is pretty much the shape we needed it to be. I didn't show the rest of the boring operation on the lathe because, you know, I think you'd seen what I was doing and you kind of got the gist. And I don't want to make the video tedious for you. So at the moment, I'm just putting in the slots at the end here for the downpipe clamp. This is the end the downpipe will interface with, and there's going to be a clamp here on the end. So I've got 3 slots in already at the 6, 9 and 3 o'clock, and we're just going to put the 12 o'clock position slot in now. They're 3 millimeters wide by 18 millimeters long, and they'll be completely covered by the clamp. At this end we have the diameter for the silencer. This is where it will go into the silencer. We've got our flange machined on there so that we've got a stop for the end of the silencer, and then we're through board to the diameter of the downpipe. So we'll have no gas restrictions at all, no issues like that. Not that it's, you know, a performance machine, but obviously if we introduce sort of problems, introduce resistance, then, you know, potentially we could lose what meager performance we've already got. So I'll do a little bit of milling, and then hopefully the part will be finished by the cleanup, and we'll be able to test fit it to the bike. So I've already touched off. As you can see, we're just touching the surface there. I've set the stop on the table as well so that the slots are all the same length, and obviously indexed off this this feature here. I don't have a rotary table, which would be the ideal thing for this milling machine. So I'm just indexing using the high-tech eyeball and engineer square method, but it seems to be working anyway. We're getting near enough. So I've just put a bit of travel on with the knee, and taking about ½ mil at a time, there or thereabouts, and it's munching through it quite nicely. Sorry about the wobble on the camera. You are sitting on the milling table, and not a particularly robust camera mount. Battery's getting a little bit low on the camera, so I'm hoping that you get to see everything, but if not, I think you get the idea. Taking it steady because I don't really want to break this milling cutter, but it seems to be doing a good job. The next cut might be the one, I think. Maybe not. No, this is the one. Alrighty, so that is our 4 slots milled. We just get some of the fine dust out of there. There we go. So that is the end of our exhaust adapter. Let me just grab the clamp. So here we go. That's the size of clamp that we're going to use. And that should do the job admirably, I think. So I'll get it cleaned up and deburred, and then we'll have a bit of a test fit. Right, so there's our extension piece fitted to the silencer. It's clamped at this end. Nice and solid, nice good mechanical connection. And then we have our other clamp, which will fit there. Wrong way around. Which will fit there and connect the assembly to the downpipe. And so the next step is to fit it to the bike and see where we are. And hopefully we've solved the problem, which I think it will be fine. So let's go over to the bike and have a look. Right, hopefully you can see a good view of the side of the bike there. You are currently magnetically mounted to the top of the parts washer, so I think that's a new one for you. And we're going to go for a little bit of a trial fit. I'm going to use a temporary nut and bolt to secure the silencer bracket to the footrest hanger, largely because I can't find the nut that holds the pillion footrest on. It's got to be in here somewhere, but this workshop is an absolute tip at the moment. I can't even think straight in here, so I'll have to have a good tidy up and search the place from top to bottom. I'm sure it will turn up, but for now we're just going to do a dry fit anyway, so it doesn't really matter. So I'm going to hopefully not get in your way too much, although I think it's inevitable that I will block your view slightly from time to time. I shall certainly do my best to give you a good view of what's going on. So first thing we need to do is just slip the downpipe into the extension piece until we get somewhere near with the bracket, which is about there. And then I've made this spacer, might need slitting down a little bit, but as you can see on the silencer here, the Kickstarter's been having an argument with the silencer at some point, so I just want to make sure that there's enough clearance between the Kickstarter at its sort of maximum of its travel and the silencer. But we can test and adjust as we need to, really. But let's get it bolted together and clamped up. It'd be nice if I could get the nut to start, wouldn't it? There we go. It's just me. that little nip. Just take up the gap. We don't need to go bananas, but you do need to make sure that things are reasonably securely fitted, otherwise you get false results. So, like my socks, incredibly jazzy. Got several pairs of these in different striking colours. I quite like them. And you can see I've got my bins on today so that I can see what I'm doing. Okay, there we have it. I don't know if I tightened that up. Yes, I did. So we've got a good mechanical connection there for our exhaust, and it looks a little bit clumsy, I suppose, with the two clamps, but to use up parts that we've already got and you know, keep the costs down a little bit, I think it's a solution, and I think it will work. And obviously that's a dry fit there. I haven't used any sealant or anything. What I use on exhausts, and I've used for quite a number of years, is this stuff. Let me just get it into focus. It's a Loctite 5990, and it is a silicone, but it's a copper silicone, and it's good up to about 300 degrees C, and you're not going to get 300 degrees C on a motorbike exhaust. But the good thing about it is it's also oil resistant, which on a two-stroke, obviously you get an oily exhaust, you tend to get horrible dribbles from, you know, any gaps. But this stuff is absolutely brilliant. I used to use it on The Simpsons, and they generally, if you're going to get a leak on The Simpsons, they dribble from the downpipe to cylinder head joint, and it completely eliminates. Even with a copper washer, you would get it, but it completely eliminates it. And I don't very often on my channel say don't do something or don't use something, but yeah, especially on the two strokes, ordinary exhaust paste, just garbage, absolute garbage. What it does is it dries out and it becomes a almost like a ceramic type material, and it just absorbs the oil, and then it starts to break up, and then it just all leaks out. So yeah, I would not use that. This is a little bit more expensive, but that's the stuff I use, and I'd just like to point out they don't pay me to say that. I have to fork out my own money, but yeah, when you find a good product, you stick with it, don't you? So that's what I'll be using when I assemble the exhaust for the final time, and we get it all together. So I'm just going to give you one more flash of my jazzy socks, and we're going to press the Kickstarter down and just make sure we've got clearance. There we go, we have. And the observant among you will notice there's no footrest fitted, because it's here, and I'm in the process of straightening out the footrest. You'll remember that it was pointed up here somewhere at a jaunty angle, and I think that someone had done that to clear the exhaust, but we shouldn't have that issue now. So I'm probably going to have to take that into work and use oxyacetylene to get enough heat so that we don't end up snapping it. But that's another story, and I think that we can say we've done the exhaust.